Pre-algebra lesson 20, multiples and least common multiple. Now, when we're talking about multiples, we want to think back to our times tables. And multiples are kind of like synonymous with the answers to our times tables. For example, here we have the multiples of 3. The multiples of 3 would be 3, 6, 9, 12, 15, 18, etc. Or another way to think of multiples is counting by a particular number. Like if I were to count by nines, I could see here, I would count 9, 18, 27, 36, 45, 54. So multiples are the answers to their times tables, or if you were to count by a specific number. And the interesting thing about a multiple is you can have a common multiple. Like for example, the number 18 is a common multiple of 9 and of the number 3. So we see that 3 times 6 equals 18, and then we see 9 times 2 equals 18. So 18 has common multiples of 3 and 9. Now, what we're going to be working on is how to list multiples of different numbers and then how to find what's called the least common multiple, or as your book will refer to as the LCM. Alright, so let's get started with multiples. And actually we're going to start off with a practice problem. So let's see here. Practice problems, we'll do practice A and B. So practice A asks me to find all the multiples of 7 that are less than 56. So all I have to do is count by 7s and list all those numbers that are smaller than 56. So let's go over to our work paper. I'll write down practice A. And I need to count all the multiples of 7. So the first multiple of 7, well, that would obviously be 7. 7 times 1, 7. Okay. Next is 14, then 21. Plus 7 is 28. And if you have trouble remembering your times tables, you can always just add 7 to each number. But by now we should be able to count by 7s, and we should have all that memorized. Next is 35, then 42, then 49, and then after 49 comes, 56? Oh, wait! The problem said to find all the multiples less than 56, so 56 cannot be part of my answer, but all of these will be. Okay. Now, there's another way that they might do this problem, which is in practice B. Practice B, they say find all the multiples of the number 6 that are greater than 29 and less than 50. So what I have to do is I have to start at the number 29. So let's go here, we'll write down practice B. So I have to find multiples of 6 that are bigger than 29, but then smaller than 50. So I'll put 50 all the way over here. Alright, so if we think about counting by 6s, I gotta get past 29. Well, if I remember that 6 times 4 is 24, so 6 times 5 is 30, so my first one will be 30. So not counting 29, I have 30, then 36, then 42, 48, and then 54, but that's bigger than 50, so these would be my multiples of 6 that the problem is asking for. So that's how multiples work, and there's a couple example problems of what you'll need to do on your homework. Now let's talk about least common multiple. Okay, least common multiple can be really, really simple if we're using small numbers. So for example, if I have numbers 2, 4, and let's see here, 6. Okay, I need to find the least common multiple of these 3 numbers. Well, I can just count multiples of each numbers. Typically, I like to start with the largest number because that's the fastest way to find out. So I'll say 6, 12, 18, 24. Hey, wait a second. I know 4 goes into 24, so I've definitely got something here. So then I'll count by 4s. Let's see here. 4, 8, 12. Ooh, they both have 12. I missed that. Okay, now let's see if 2 also has 12. So let's see, 2, 4, 6, 8, 10. Yep, it also has 12. Oh, wait, these 2 also have 8. Ooh, but no 8 over here, so I can't use that. These 2 have 6, but there's no 6 in the middle, so it looks like my least common multiple is going to be 12. Least being the lowest, and common meaning all 3 numbers possess it. So it could be the number 12. That is the LCM. So LCM equals 12. Now, it's not always going to be that easy. We have to figure out how to do this with larger numbers as well. Like, for example, in our practice problem, we have to find the least common multiple of 35, 60, and 90. So let's talk about how we do this with larger numbers. And it has to do with a little bit of number theory and some facts about prime numbers, which means we're going to have to do some factor trees or some division towers. So the three numbers I have to find the least common multiple of are 35, 60, and 90. Now I could start counting by 90s, but that's going to take a while. So what I'm going to do is I'm going to factor each number into its prime sets. So I'll use a division tower on 35. Actually, I'll go down with it. So normally you guys see me use my division towers and go up. You can also go down. And remember, if you're doing a division tower, whether you're going up or down, you have to always divide by a prime number. So what's a prime number that can go into 35? Yep, 5 is. 5 goes into 35 7 times. And when you divide into a prime number, or when you divide, you just keep going until you get prime numbers. So 35 is going to be 5.7. That is 35's prime numbers. Now let's do 60. We'll do the same thing. We'll do a division tower again. I know that 2 will go into 60, and 2 is prime. 2 goes into 60 30 times. Let's see here. 2 goes into 30 as well. Also prime. That goes in 15 times. And then I know 5 goes into 15 3 times. I got a prime number on the bottom, so I know I'm done. 60 is going to be 2.2.3.5. Great. Now for 90, I'm going to go ahead and do a factor tree. 90 I can split into 9 and 10. And notice I'm using composite numbers here because factor trees are not as picky. As long as I get prime numbers at the bottom of all my roots of the tree, then I know I'm good to go. I don't have to have prime numbers every time I divide. That's one of the reasons why I prefer factor trees. There's a lot more freedom as far as division. Now 9 will factor into 3 and 3. Those are primes. And then notice when I do my factor trees, I circle my primes at the bottom so I don't lose them or lose track of them. And then 10 will be 2 and 5. So we've got some more primes there, which means 90 is going to be 2.3.3.5. Great. I've factored all three of these numbers. Now you're wondering, why in the world did I do this? Well, to find the LCM, of course. So the way that we do this for the LCM, it's going to be the opposite of greatest common factor. If you remember, for greatest common factor, we would only look for the numbers that all three sets had, and we would take the least amount of each number that the sets had in common. In this case, the greatest common factor would just be 5, because that's the only number they all have in common. But since I'm looking for the least common multiple, instead of taking the least amount of each number, I'm going to take the most of every number that each has. I don't care if it's in common or not. I'm taking the most of each number. So let's start with 2. Which number has the most 2's? 60 does. So I'm going to take 2 2's. 2.2. Now, which one has the most 3's? 90 does. I'll take 3.3. We'll cancel out the other 3's, the other 2's, the ones we're not taking. Now, when it comes to 5's, each of them have 5. Doesn't matter which one I take. I just need to take one of them. So I'll go ahead and I'll take this 5 and I'll cross out the other 2. So now I put .5. And then lastly, there's a 7. So I'll take that 1 7. So remember, this differs from greatest common factor. Instead of only taking common numbers, I'm taking every number. And instead of taking the least amount, I am taking the most. So once I take all of these numbers, I multiply them, and they will equal the LCM, or the least common multiple. This works every single time. So let's go ahead and multiply them and find the answer. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Ooh, 36 times 5. Let's see here. 30 times 5 is 180. 6 times 5 is 30. 180 plus 30, 210. All right, and then let's see here. 200 times 7 would be 1,400, and then 10 times 7 would be 70, so 1,470. 1,470. Holy cow. Well, let's check and see if that's right. Oh, no, it's not right. Let's see here. That means I need to double check my multiplication, so let's try this again. 2 times 2 is 4. Definitely didn't mess that one up. 4 times 3, definitely 12. 3 times 12, still 36. Let's see here. 36 times 5. I bet you I messed up either on this step or this step. Let's see here. 36 times 5. 30 times 5, 150. 6 times 5, 30. 150 plus 30, 180. That's my mistake. I put 210. What was I thinking? Okay, 180. And then let's see here. 180 times 7. All right. Let's see here. 7 times 100 is 700. 7 times 8 or 80 would be 560. So 700 plus 560 would be 1260. So the least common multiple should be 1260. So assuming that you're actually writing this out instead of trying to do it in your head like I just did, you should have gotten the right answer the first time. Now let's see here. 1260 is the right answer. If only I had written down my work instead of trying to do it all in my head. Oh well. Well, we've got the right answer, and the method works as long as you multiply correctly, and that's how we find least common multiple. If you have any questions, let me know on the school website, and I'll see you in the next video.